Hello, welcome to our video. We want to look at classification of number sets. If you're solving maths at every level, you are required to understand the number sets you are using. So numbers are generally classified into so many groups, and we want to look at those sets. This will help you in every stage of mathematics. Let's go quickly. Number one, we have the natural numbers. The natural numbers. These are also called the counting numbers. These numbers are conventionally represented with n. These number sets are conventionally represented with n, and the numbers you have in this set, this is braces used to represent numbers in a set, is an infinite set, of course. But the first counting number is 1. That's the smallest natural number. You have 2, you have 3, and then continues to infinity. So these are practically whole numbers, the first numbers that a child learns when the child starts counting. So these are the natural numbers. Now, after the natural numbers, we have the second one we call the whole numbers. The whole numbers. The whole numbers are conventionally represented by W. These are just like the counting or the natural numbers, but with an inclusion of 0. This is 0, 1, 2, 3. So these are the whole numbers. So you see the relationship between the whole and the natural number. The only difference there is 0. And then we'll move on to the integers. The integers. Integers are represented with the letter Z. At every stage of mathematics, this is a convention. They are represented with the letters D. They are infinite sets. Integers include all negative whole numbers. This means every negative whole number you can think of going to the left of the number line. All negative whole numbers. I'm just giving some examples. 0, 0 is an integer. 1, 2, 3, and so on and so forth. These are integers. These ones here are referred to as positive integers, while these are negative integer. 0 is neither positive nor negative, but it's also referred to as an integer. After integers, we have number 4 classification. We have rational numbers. Rational numbers are conventionally represented by Q. These are numbers that can be expressed as fraction. They can be expressed as fraction, as A over B, where A, this thing means an element, where A is an element of integer, where A is an integer. That means this A can be any of these numbers. A is an element of integer, and B is also an integer, but B cannot be 0. So when any number, any fraction you can think of, if you can write a number as a common fraction, that number is a rational number. Examples include 2 over 3 minus 2 over 4 minus 6 over 7. Any number that can be written as a fraction is referred to as a rational number. Notice that these denominators cannot be 0. If a 0 divides a number, it's undefined, mathematically undefined. So these are rational numbers. And look at their definition. Very important for you to note this. Now we have number 5. We have real numbers. Real numbers. I want you to take note of this. Real numbers include every number that we've mentioned from here. The natural numbers, the whole numbers, the integers, the rational numbers. Another way of saying it, that a real number is any number that you can find on the number line. You can find these numbers on the number line. Real numbers can be found on the number line. Now, Real numbers also include decimals, fractions. So you should know, because conventionally in geometry, a line is made up of infinite number of points. So on this line, you have infinite number of points, and each of those points represents a real number. So every number here is a real number, including decimals. For example, a number here on this number line can be 3.418. It's also considered as a real number. So natural numbers are natural numbers, whole numbers, integers, rational numbers. All these are real numbers, including decimals. Some decimals are rational, while some decimals are not rational. So quickly, real numbers are represented with R. Now we have 6. We have the irrational numbers. The irrational numbers. Irrational numbers. Irrational numbers are represented as R/Q, and a good examples are some decimals. For example, square root of 2, square root of 3. These are square root of any number that cannot be written as a fraction. Please note that 22/7 is rational, even though we take it as pi sometimes is rational. So this is not an irrational number. So it's a rational number because these two are integers. And then finally we have imaginary numbers. We have imaginary numbers. Imaginary numbers are numbers that are negative square roots. Okay, numbers like this: negative square root of 16. And notice that this number can be written as root -1 times root 16. And then this -1 can be replaced with I. That's a conventional way of writing it. This is 4, so this could be written as 4I. So these are imaginary numbers. The next set of numbers are what we call the complex numbers. A complex numbers, see, complex numbers are a combination of, they can be written in this form: A plus BI, where this represents the real part and this represents the imaginary part. All right, a good example is if you have something like 3 plus 4i, this is real and this is imaginary. This can also be written as 3 plus 4 root I root 1. All right, this is where we are going to pause. I'm going to give you, based on what we've done so far, I'm going to give you something to look at and then solve. And next time on this channel, we are going to look at that problem. But first of all, let me give you this problem to write down and solve.